Hello, we have the anatomy of a power drill here. So essentially these are all the components taken out of the basic plastic shell. We have the trigger, motor, the gearbox here, the clutch, and the chuck. So starting with the trigger, we have obviously where the battery is inserted, the trigger that completes the circuit and runs the motor. Then we also have a selector switch here, so this will run the drill forward or clockwise to drive screws in and drill through stuff. We have the neutral configuration, which stops the drill or the motor from running. Then we have obviously reverse, which is counterclockwise to take screws out, etc. And then runs up to the motor, basic DC electric motor. We have a little spur gear here, and that basically will connect into the center of the gearbox. There are supposed to be actually 5 gears all around the gear, but I've taken them out for simplicity. And then we have here the gearbox, obviously, and basically we can take the gearbox out via these little pins here. I have taken the gearbox out of the clutch. Essentially what we have here is a planetary gear train, so taking that off. If I can just pop this whole unit out, you can take a look. There we go. So again, there's actually 5 gears on here. This is basically where the engine would connect. We have basically, this is fixed to the frame. We have 2 different radii of internal gears, and this is fixed to the frame, so this acts as ground. And then within that, this unit rotates. So essentially we have the input here, then this rotates against the ground, rotating this piece here, and then going down a layer, we have this, that's kind of stuck, but get the idea, which is similar unit of a different gear radius, which again, these gears will rotate and rotate against the internal gears that are fixed, then rotate this whole unit, and then you have the gearbox output. So this will go into the clutch. Gearbox output goes right here. And what happens actually is, during normal drilling conditions, this internal gear is fixed to this outer frame here by a mechanism we'll discuss a little later here. And basically what happens is, obviously, this is allowed to rotate in it as a planetary gear system. The clutch's job is basically to disengage this motion, and as a result, when this disengaging happens, this will spin. The entire thing will spin with the motion of the gearbox output and will prevent any rotational velocity in the chuck. And this is done by an interesting system, if I can pull this out. So basically this internal gear is obviously easily removable. It's just a simple press fit in there. It has this groove and these little lips, and there's 6 of them, and there's also, as you may notice, 6 ball bearings in here. Essentially, these ball bearings is what's holding this internal gear to the frame. So obviously this would be in here, and basically these little lips would be pressing against the ball bearing, and the ball bearing would be providing an obstacle that this cannot turn against. These little ball bearings, they sit on these little pins. If I can take that out, see, little pins. These can actually be pushed down, as you can see. Essentially what you have is one giant spring in this clutch mechanism, and that is keeping pressure on all these pins. The spring force is adjusted using this screw mechanism. So the more compressive force, the less likely the slip is. You can actually kind of see the motion I'm talking about when I tighten the clutch. You can see those little bearings pop back up. These little bearings can kind of sit in those little slots. And what this does is, when they're in these slots like this, is this internal gear is free to move along with the entire shaft. When you're drilling, essentially, there's going to be obviously a torque applied onto this internal gear. And now that torque is resisted by each of these bearings, meaning that it'll be held in place. And these bearings, due to the torque, will have a force applied, pushing them down into these slots. Now when that force exceeds the spring force pushing them back up, they will recess into their respective slots, allowing for the internal gear to slip over each of them, disengaging the drive and preventing the chuck from spinning. Unfortunately, I would have liked to take the actual spring out, showing that off, but this is old drill. The chuck's being stubborn. It does not want to undo from the chuck screw. So we'll leave it at that. Thank you for watching.